Okay, hello everyone. Welcome to a new section on the relational model. So in the last section, we have introduced the ER model already. So we know ER model is a very powerful but a very simple model. With ER model, we can model the real-world information about the applications you choose, which can show some ER diagrams to cover the entities, relationships, as well as very diverse constraints on this information we have. However, we know ER model is very hard to store the information in our computers because we cannot store the diagrams in our computers, right? And therefore, we need to have some other models which can translate information we have in the ER model to some new representations. In this way, we are able to store the data we have into our database systems. Therefore, we will introduce the relational model in this section. Before we cover this section, I have a reminder for you. In this week, we have one deadline for the project. The stage 1 will be due by this Friday midnight. So the submission will be in one single PDF document, and more information has been covered in the project description already. You need to provide your team information, the team name, team members, as well as contact information of all the team members. So the submission will be in one single PDF document to be uploaded to Canvas. We have created a link already for you to upload. So the stage 1 report should be submitted to Canvas. The emailed submission will be accepted. And in the next week, we will also have another deadline for the homework 1. It will also be due by the Friday. And the submission will be also very similar in one single PDF document to be uploaded to the Canvas system. And I will also send you another reminder in the next week for the homework 1 as well. Okay, let's talk about the relational model. Relational model is another model we can use to model the real-world application information. Compared with the ER model, relational model is much simpler because it has only one single concept. It's called a relation, and everything will be represented as relations. So in other words, all the diagrams we have drawn in the ER model, we need to have a translation rules to translate the information into relations, which will be covered in this section. So this section will have two main parts. Before we introduce the translation rules, I'd like to provide a description about relations first, so you can know what we are doing in this relational model and why we are learning this. We plan to cover the basic information about relational model in this week, and in the next week, we will talk about the translation rules in detail for you. Before we introduce the relational model, we still need to provide the motivation why we should study this. And I still borrow slides we used in the previous section. When we are building a database applications, we have several key steps. The first step will be picking an application domain which we plan to work on, right? It's a topic we need to work on for the application. And then we need to do some conceptual design. And we need to discuss with the teammates about what to model in the application domain. And based on our discussion and brainstorming, we need to have a language to describe our discussion or brainstorming results. And we need to have modeling language to express our ideas. Then ER model is the most popular of such language for the only state design of our application in the database systems. So we can just need to show some very basic ER diagrams with rectangles, with a diamond and ovals and etc. Right? And the output of this stage will be a ER diagram of this application domain. It covers these entities, attributes, relationships, as well as very diverse constraints on these kinds of the basic structures. This is what we covered in the previous section. We know the ER model is very important. And then we need to move to the next step, and we need to pick a database system. Normally, we can use a relational database system, which will also be the main focus for our course. And based on our database system, we need to translate the ER design into some relational schema. The main reason is because the ER diagram is very hard to store in the computers. We cannot store a diagram in our computer, right? We need to store the data into some tables instead. Therefore, we need to translate the ER diagram into some tables or relations in this section. And we will use a set of rules to translate the ER diagram into relational schema, which is also called relation or tables. And we generally don't differentiate them from each other. You can call them a relational schema or relation or tables. It doesn't matter. If it is easier for you to understand this, you can just think this relational schema as a tables for you. And we have a set of schema refinement rules to transform the above relational schema into some good ones. So this will be the main focus for the following sections. It's called relational design as well as the relational algebra. So in this section, we mainly focus on this step. We can use a set of rules to translate ER diagrams into relations, which will be the main focus for us in this section. Before that, we need to talk about the relations first. We need to know some basic information about relations. Then we can cover the rules to the translations. We have a bunch of rules to translate entities, attributes, relationships, as well as subclass, as well as working in sets and etc. into relations. So different kinds of information we will have different rules, and we'll cover this for you later.